Hello again, and welcome back to the second episode of our tech tutorial series. This time we're going to be dealing with Git, GitHub, and developing code for Arduino. It could really be any code in general, or in some cases hardware files, which I happen to use GitHub for too as well. In this case, we're going to be using the basic example sketch Blink to show how we use Git in a development type of environment. Basically, the flow will be we'll create a repo, we'll push this up as the master base code, and then when we make changes, we're going to create a branch and make the change, test it a little bit, and then push it back into the master. And the other way to do that is when you create new features, you'll create a branch with the feature name, and that way you'll have all the different branches, and you can keep track of all the versions, and it makes it easier if something goes wrong or you need to resolve issues between various features that are added over time. Anyways, where we'll get started is if you're in the Windows environment, there's a few different ways to go about getting Git. The easiest way is to just download Git for Windows, install it, and then you're pretty much good to go. You can get a GUI for it as well. I happen to use the command line tools, and I'm used to them, so that's fine with me. As you can see, there's GUI clients. There's another route you can go, which allows you to install the Linux command line tools. This is called Cygwin, which gives you all the basic native command line tools that you'll find in a Linux environment, and I happen to like those, so I install that. If you go that route, the Arduino environment basically gives you the Arduino has a tutorial for building the IDE, and it gives you kind of a rundown of the basic things you need. So if you install Cygwin and you follow this, they'll tell you to install Git, Make, GCC, MinGW, and G++. So these are basically all your GNU open source C, C++, and all those compilers and all the utilities to run that. I believe the default version of Cygwin installs these tools by default now. And if you're on OS X or Linux, of course, you pretty much are good to go. Basically, I'm going to just show you the Windows version of this. So I've installed Cygwin, and via that I've done these. Now, one of the caveats is sometimes when you install it, it messes up your path. And I happen to need to use the old Arduino path. So what I do is I go Computer Properties, Advanced System Settings, and then that'll give you this window, which you go to the Environment Properties or Environment Variables, and then that'll bring up your path, which is right here. So I've kind of copy and pasted it here. And one of the things I've done is I've added the path to my Arduino AVR tools bin folder location, and that way when it looks for Make or AVR GCC, it's going to point to those first. Then sometimes I do development using a more updated tools set in the WinAVR. This is the 110 branch of it, one of the more updated ones. I think this is the last update of WinAVR. And if I need that, I'll just remove this and then let those run first. You'll notice I've also put Cygwin in here, and this allows me to run the Linux command line tools in the Windows command box. So I have access to LS and all that fun stuff. So that's part of the reason why I have that added in there. And you'll also see when you install Windows, Git for Windows, it'll put this path in there. So if you install that route, you don't really have to worry about your path. So let's go back to actually dealing with Git and creating a repo and then pushing that up. So I've already created a repo, and it's called Git Blink Tutorial. So this is kind of basic name just to show, if somebody wants to come to my repo, they'll be able to see it. When you first create the repo, you'll name it, and then it'll bring you to this. Now, I've already ran some of these commands, but basically this creates a file called readme.md, which is a markdown markup file for your readme. And then you want to initialize your Git repo inside your folder. Now, as you happen to see, I'm inside my Dropbox folder here, which points to where my Blink sketch resides. So that's where I'm going to be developing. I've already initialized it. I've already run touch readme. I've already run git init, and I've already ran add readme and add blink. As you can see, one of the problems when you're working in the cross platforms between Windows, Linux, and OS X is the line endings. You may want to go read about this on Stack Exchange and decide how you want to handle this. This is all kind of personal reference. I have versions of this code on all 3 platforms, so I choose to rectify this on the client side, or however you want to call it. Whenever I pull that down, I do the OS X or the OS's handling of it. But you may want to do a different one. If this is too confusing for you, just kind of ignore it. So basically, we've added these files in. We've created it, we've added them in, and we're about to add our remote origin, which would be this GitHub, the repo on GitHub, and then we're going to push it up there for the first time. So I'm going to back up just a little bit, and I'm going to go to the base GitHub page here. When you first set up your GitHub account, it's a good idea to click on the Setup Git. And this will tell you all the little things about setting it up. Like here, you want to set up your username as a global variable, so that way you'll always kind of have it when you launch your tools. Same with your email account, which is used as part of the security. And then depending on what OS you're on, there's password caching. So you want to read this part and pay close attention to when you install that. And that changes, which is why I'm not showing it. If you want to use SSH, you'll go that route and install keys and pair them. This way I just use the credential helper on Windows, so you would download this, install it, send your HTTP password one time, and then it'll keep cached for whatever you set the options for. So it's a really good idea to, as soon as you set up your GitHub account, run the setup git, and then you'll be ready to go exactly where we're starting from right here. So I'm going to close that down, and then we'll go over to here and we'll run the last couple operations. You can just go ahead and cut and paste these. This is the quickest way to do it. And then you can run that, and the same thing with the git push master. And what this is going to do is go ahead and push this whole everything I've added. And one thing we didn't do is a commit, so you're going to see it's going to complain to me because there's no commit on it, so it doesn't match any. So what we need to do is go ahead and do a git commit /m. If I could spell correctly, it would be nice. And then we'll say our initial upload to GitHub. And as you can see, now we went ahead and pushed it up. Now if I refresh this page, now we have our README and our actual sketch. And if you look, there's our code. So there we go. That's how you push all that stuff up to GitHub. Okay, so now we have our repo up on GitHub. So what do we do? Well, basically, we're going to go ahead and make our change here. I'm going to say pin 11 in my case, and if you're using a normal Arduino, this would be pin 13. I'm going to save this, and then what I'll do is we'll go git add that file back again, blink.ino. Then we want to git commit again, because we made a change, git commit /m, and then we're going to say updated blink pin. Then we do git push origin master. And now we've gone ahead and updated that. Now that's generally not the way you want to do your workflow, but that shows you a quick way to go ahead and update this. So if I refresh the page, you'll see we've changed to pin 11 now. And here's where I'm going to show you where GitHub's really cool. And we're going to go back to our main heading of this, and we've just created commits on this. So we can click on the commits and we can show the first one. There's that. So you can see pin 2. Or we can go back. Here, we'll just go show diff stats. And it shows you the difference between them. So we'll go back and then we'll click on this one. And look, it shows you where it's changed. So that's one of the really cool points about using the version control systems, is you can definitely just click in there and see what the changes have been. So that's kind of why, part of the reason why we use this. And GitHub has a lot of powerful tools, as you can see, for visualizing this. So now, how do we properly handle this if we're going to add features? One of the ways to do this is you can create a new branch. You'll do a git checkout, and if you add the /b, that actually does creates a branch at the same time. And we'll call this new feature fade. So now we're in a new branch. That's the new feature fade. So we can go in here and change this code. In fact, we can kind of just we could maybe even like just delete this out. We're just starting from a blank slate. So we'll save this file, and then we can go into here and we'll go into, we'll git add the blink.ino. Then we want to git commit /m new branch for a new feature. Then we want to git push origin, but now we want to do the new feature fade. So now we've created a new branch and pushed that code up. So if we go back to the main repo, you'll see we now have two branches. We have the master branch and the new feature branch. So if I click in here, you'll see we removed that out. This is the proper way to develop. So now we can go ahead and start coding on this, and we decided that maybe we didn't like this branch. We can just throw it away and not ever have to worry about it ever affecting our main master branch of the code. So whenever you release your code, you can release your master, or like say a bleeding edge version of it and a branch of it. That way you can have like all of your newest updates that might break stuff. You put them in the bleeding edge, and then the master is your most stable working branch or something like that. There's different ways to handle that, but that's basically the workflow. So for those new to using Git and GitHub, that's basically how all of this works. So you know, I might go over to the fade tutorial here. We can just do something like Arduino examples fade. I'll bring that into here, and say we want to just use this, so we can just copy and paste this out of here, put that into here as our new feature. And guess what? We've already updated our pin, so we LED pin, make sure it's labeled the same. which it's not. There we go. So make sure everything's labeled the same so we don't have any compile errors or anything like that, and okay, that should work. So this is our new feature. Instead of the LED just blinking on and off, it's now going to fade in and out, get brighter and dimmer slowly, and we've gone ahead and do that. So basically what you would do is you let me save it. I don't think I saved it, so it's going to complain at me here. Oops. Okay, so now what we're going to do is we're going to git add again the blink file. Whatever you want to add, whatever files you've changed, you add them in. That's what we're doing right now. Every time you make the change, you add it into your change log. That's basically what you're doing. So we're adding it in. Then we're going to do our pushing it back, or our commit. We'll do our commit. And then now we've updated to a fading LED action. Okay, and then we can do git push origin, and then of course it's our new feature, fade branch. Oops. Typos. Okay, and now we'll go ahead and check it. As I can show you, we've gone ahead and updated it. And there we go, our fading's in there. So now we want to switch back to the master branch if we wanted to. Now I'm not going to, well, I guess I can undo it, but you would go git branch master. Oops. Git checkout. Sorry, master. Now, what you could do is you just do like a git merge, and then you would merge in from new feature fade. Now, if I hit enter, we'd merge in, but then we'd lose blink. And I'm going to save some of this for, never mind, I'll go ahead and continue on with it. We'll go ahead and merge it in just so you see how you merge. So when you read the fast forward, what that means, we've updated to our new branch ID. We've merged that into the master ID, and it's fast forward. Now our pointer where our head is into our project is right now updated to the latest versioning of the code. So if we click in master, ooh, it didn't do it. Oh, that's because I didn't push it up, that's right. So then you would just do git push origin master. There I go, typing push wrong again. On my base repo, on my local repo, it was updated, but I didn't push it up, so. Okay, now we're fading, and we used GitHub to add in a new feature. I hope this wasn't too confusing for everybody, but after you do it for a few times, you'll get the hang of it. So I suggest you create a GitHub account, and then just do some basic manipulation, just like I did. Change the LED pin, save it, and then restore it. Add a feature using branching, and then you'll get the hang of using Git really quickly. Now, say I needed to go back and I didn't like this, you can of course just go back into your commit history. So all of our commits are in here. So of course I could go back right into here and see our original code and some of our changes. So that's basically one of the greatest advantages of using version control system, especially Git, because it's so easy to use and it works so well. You have a repo somewhere else and it's not on your local computer or wherever you're working from. So if we were to into my temp directory here, and what I would basically do is something called a git clone. So we'll git clone, and then we'll copy this right here, paste it in, and this is going to clone all of the code, including the Git files, so that we have our commit history and everything. So we're going to go ahead and run that, and that brings everything in. So if we list, and we then go into this folder here, we have our entire project. So I can initialize in here and start working on that. Since we're probably already initialized, I think I might be able to work with this. But I'm going to back out here, and then we can del temp. We don't need it. Yes. So we don't need that right now. We've already cloned it and we have our thing. So let's assume we've already cloned it and we're working in the current directory right now. The other things we need to know about would be pulling down files so that we can update to the newest version. There's two different ways to do that. There's a git fetch and also a git pull. The difference between the two is a git pull runs a git fetch and then it merges everything. So it fast forwards and pushes the pointer to the head up to the latest quote-unquote version. That may or may not be a good thing, which is why there's two different versions of that. So depending on what you need to do, you would either run a git fetch or a git pull. So if you're working with like the Arduino environment, if I click up here, they say if you want to update everything, you would do a git pull and a git update, which would basically update everything. It'll run the side task to merge everything in. So basically the way you do it, if it's safe, is a git pull. If it's not safe, you do a git fetch, and then you can kind of step your way through the changes. So I kind of wanted to talk about that if you're working with other repos or you need to update your code. It's good to get the other side of it when you're pulling files down. It's not just one way where you're always pushing it up. You're going to be pulling them down a lot, doing a lot of pulls, a lot of fetches, and a lot of reconciliation. So it's important to kind of understand this part of that. And hopefully I've piqued your interest a little bit and you'll start researching it out. There's a lot of great references on the internet about Git, so hopefully that'll help you out with that. The only other thing I want to leave you with before we go, that is of course, excuse me, the other thing I want to leave you with would be pull requests. This would be you've made a branch feature to a project that's somebody else's, and you want to contribute it to it, and you've already made that feature, you've built it, you have a branch of it, and what you do is you issue a pull request. So that's like a statement saying, hey guys, here's this feature, come grab it. Now an example of that is I do some updates to Linguist, which is GitHub's method of when you upload code, they decide what kind of code it is, Ruby, C, Arduino, whatever. My latest update to that would be adding in Eagle board files. So if we scroll down to here, you'll see from me, here's an update to this. At some point they'll get to it, but it takes some time because you got to make sure when they add some of these updates it doesn't break stuff downstream and there's no conflict. So when you're working with a big project such as this, there's over 500 forks of it. It can be difficult to reconcile everything. So it's important to kind of know that end of things too. So I just wanted to briefly cover that too. So I hope this tutorial was a big help to everybody. And if you found that it helped you out and you're going to start using Git when you're programming, please give me a thumbs up and I'll appreciate it, and leave some comments in the comment section. And also if you want to come check out some of my repositories, you can come by my GitHub repo. I got hardware repos, I have a fork of the Arduino, I have full builds that I've already distributed, and I also contribute to Linguist and other stuff too. So if you kind of want to check out my repo, that would be cool too. So thank you and enjoy. Bye.